All right, team. So we are going to talk about the parent rational function. Okay. So today's objective is to observe how the rational function f of x equals 1 over x or 1 divided by x behaves and to analyze how horizontal and vertical asymptotes affect the graph. Okay. So as you heard me say, right, I kind of said 1 divided by x. So our main operation here is division. Okay. And that's no different from any of the other functions that we looked at, right? Like the absolute value function, the main operation there was the distance from 2 points, right? The same thing with a quadratic function, right? The main operation there is squaring an expression. And in this case here, we're dividing, right? And with that comes certain vocabulary, right? So let's in this exploration, we're going to assume we don't know it's a function yet. And we're going to look at some inputs, at some outputs. Now, because we are talking about division, this fraction here has certain specific names, right? Like, for example, whatever number that we're dividing, like the 1 in this case, that's our dividend. And we know that this little symbol here, the little bar, that's division, right? We're talking about division here. And then the denominator, or the number underneath the division bar, that's our divisor. And once we get the dividend and we divide it by the divisor, we get the quotient. Okay? Now, we are talking about a function here or a relationship, so we know we have inputs and outputs, right? And from our previous knowledge, we know that x is usually the independent variable. So this is our input. And then what we get out, that's our output. All right. So what we're going to do here is just work on these problem strings, okay? Now, I highly encourage you to, pause the video if you think you could tackle these quick little operations like 1 divided by 2. You could probably snap that off. Go ahead and pause the video and try to figure it out. If you have a scratch sheet of paper with you, that'll probably be the best, okay? So here, pretty simply, we have 1 divided by 2. Now I can write that one of two ways, right? We know it's the quotient, so we can just write it as a fraction. Now, if you prefer writing it as a decimal, that's fine. In this case, it would be, in decimal form, it would be 0.5. I'm going to leave it as a fraction because I prefer fractions, right? So 1 divided by 4 is 1 over 4, or 1/4. 1 divided by 10, that's 1/10. 1 divided by 1,000 is 1/1000th. Okay? And then what we're going to do over here on the left in this table is we're going to write those inputs and outputs. I'm going to make this column my x values and this column my y values, my inputs and my outputs. And so my divisors are these guys right here. That's what I'm dividing by. And remember, we said these orange ones were our quotients. Again, our divisors, which are our inputs, like we said over here, and our quotients, which are our outputs. So I'm going to write down all my inputs. 2, 4, 10, 1,000. And then my outputs are half, 1/4, 1/10, and 1/1000th. So then we ask ourselves, what observations can we make, right, about this data that's on this table? Well, again, pause it, see if you can figure it out. we have this sentence stem here. It says, as the blank increase toward positive infinity, the blank decrease approaching blank, right? So we have 3 blanks to figure out here. Now, some of the clues here are something's increasing toward positive infinity. So if I look at this table, right, I look at my inputs and I look at my outputs, which column looks like it's approaching positive infinity? Well, if I look at my inputs, right, 2, 4, 10, 1,000, that seems to be getting bigger in the positive direction. And it's really tending towards positive infinity, right? If I keep going, this will be positive infinity. So we can say as the inputs increase toward positive infinity, well, then what happens, right? So we look at our outputs and we say, okay, well, what's happening with our outputs? So the outputs decrease. And yeah, they're getting smaller and smaller, right? This is half. This is a quarter. So this is a 0.5, 0.25, 0.1. So these values are getting smaller, right? But they're not really getting smaller really, really fast, right? They're just kind of slowing down. They're getting smaller and they're really getting closer and closer to 0. Okay, so that's the kind of like the observation that we see that's happening there. So now let's look at a different problem stem. And so it says, I wonder, since the outputs seem to approach 0 as the inputs grow towards positive infinity, what would happen if the inputs approached 0? Okay, so let's look at some values that approach 0. So we have the same deal here. We have our divisors, but now these numbers, notice they're decreasing and they're approaching 0. So we're getting really, really close to 0. What's going to happen with my outputs? Okay, so again, pause, see if you can figure out some of these answers. If you have a scratch sheet of paper with you, again, that'll probably be the best. Now, what we're doing here is we're saying, okay, well, what's 1 divided by 1? Simple. That's 1. I used the wrong pen. Sorry, guys. What's 1 divided by half? That's 2. 1 divided by a fourth? That's 4. 1 divided by 1/10? That's 10. 1 divided by 1/1000th? That's 1,000. So again, all we're doing here is we're taking the idea of division, right? If I have one thing and I divide it into halves, how many of those things do I have? I have 2 of those things. Okay. Again, same thing here, right? 1 divided by 1/4. If I take one Snickers bar and I divide it into 4 pieces, how many pieces do I get? I get 4 pieces. That's what we're talking about here. Okay, guys. So let's fill out our table just like we did before. Okay, so we have X and Y values. We have inputs, we have outputs. And our inputs are the ones underlined in blue, right? So we have 1, we are talking about half, a quarter, or a fourth, 1/10, and 1/1000th. And so our outputs are 1, 2, 4, 10, and 1,000. So the numbers look very familiar, right? Again, what it looks like is like we took the reciprocal of the inputs, okay? So we have the same statement as before. What observations can you make about the data, right? And again, we have that sentence stem, so we encourage you to pause the video, see if you can fill in the blanks, and check to see if you're correct. So here, it says, as the blank decrease approaching 0, again, we look at our data and we try to figure out which one of these are approaching 0. So if I look at my outputs, I notice these guys are growing. They're not decreasing, right? We're going 1, 2, 4, 10. Okay, so that's growing. So we're not talking about our outputs. Let's look at our inputs. 1/2, 1/4. Okay, these are decreasing. Okay, and they're approaching 0. So here, this first blank, we're talking about our inputs. As the inputs decrease, approaching 0, what happens to our outputs? The outputs increase toward positive. And if we look at this and extend, right, we're going 1, 2, 4, 10, 1,000. Oh, this will end up growing and going towards positive infinity. Okay, perfect. So now, so far, we've observed the reaction of the outputs as the inputs increase toward infinity. And we've observed the reaction of the outputs as the inputs approach 0 on the interval 0 to 1. So when I talk about the intervals from 0 to 1, we're talking about, hey, my biggest value here is 1, and we're approaching 0, so we're really not quite getting there, right? That's why I used brackets on the 1, because we're using it, and then parentheses on the 0, because we're getting close to it, but we're not really getting to 0 exactly. So now, what values could we also consider? So if you remember the inputs, we've only been looking at positive x values, positive inputs. So let's work with the negative inputs. And let's see those negative inputs as they approach negative infinity. Okay, so same deal as before. We have our inputs. Notice here our inputs are -1, -3, -9, -1,000. So if we wanted to, we could set up our table. So we have our inputs and our outputs. And our inputs are -1, -3, -9, -1,000. And again, I highly encourage you, pause the video, see if you could figure out what these outputs are going to be, what these quotients are. So you have 1 divided by -1, that's -1. 1 divided by -3, that's -1/3. 1 divided by -9, -1/9. 1 divided by -1,000, -1/1000. Okay, and then we fill in our table just like before. So -1, -1/3, -1/9, and -1/1000. Oops. All right. So again, we look at the table, we try to figure out some data. We got the same sentence stem as before. As the blank decrease toward negative infinity, the blank increase approaching blank, right? So we're looking at what is decreasing towards negative infinity. And if we look at our outputs, we have these guys look like they're decreasing, but it's tricky with negative numbers, right? The bigger the digit, the smaller it is if it's negative, right? So for example, -1 is bigger than -3. -1 is bigger than -1,000. Okay, because this is further left on the number line. And I'll draw a little number line quickly here to help you guys visualize this. Right, so that's 0. Let's say we have +3 here. We have -1 here. We have -10 here. This number right here is bigger because it's further to the right than -10. +3 is bigger than 0. +3 is bigger than -10, right? Just depending on where they are on the number line. Okay, so here it says, as the blank decrease toward negative infinity. So again, these aren't going towards negative infinity. This is really increasing and going to 0. These are getting smaller as we go. So these guys are decreasing and they're going towards negative infinity. So we're really talking about the inputs, right? So as the inputs decrease towards negative infinity, the outputs increase approaching 0. So these guys are getting really, really close to 0, but not quite getting there. All right. So finally, let's look at, let's work with negative inputs that increase towards positive infinity. So we're looking at -1/2, Let me title these columns. We have negative a fourth. We have negative 1/10. And we have negative 1/1000. So these numbers are negative inputs. Okay, they're all negative. And they're increasing, approaching zero. So this is getting closer to zero. Now let's figure out our outputs. Again, highly encourage you, pause the video, try to see if you can figure out these numbers. And again, it's okay if you can't, if you don't get them right. Okay, that's what the video is for. So here we got negative half. 1 divided by negative half, that's going to be negative 2. 1 divided by negative 1/4, that'll be negative 4. 1 divided by negative 1/10, that's negative 10. 1 divided by negative 1/1000, that's negative 1000. So we have negative 2, negative 4, negative 10, negative 1/1000. I mean, sorry, negative 1000. Again, we look at the table, try to make some observations on this data. So we have the sentence stem as the blank increase approaching zero. So again, which is approaching zero, the inputs or the outputs. And in our case, we already know that the inputs are approaching zero. So we're going to say as the inputs increase and approach zero, the outputs decrease and they go towards negative infinity. All right, that's the end of our data collection. Okay, now we're gonna go outside in a bit and try to graph these on my driveway. But one key thing I want you guys to notice is that on this data, we didn't really figure out zero, right? So let's look at that real quick. We have y equals 1 over x. That's the relation that we're looking at right now. Well, what if we looked at x equals 0? What happens at that point? So we have y equals 1 over 0, or 1 divided by 0. Now we already know that when we divide by 0, that's what? Undefined. So if x equals 0, our y value is undefined. So we don't know where that is. Now, visually, what does that mean? And that's what we're going to figure out right now. What does undefined mean visually? Okay, so thanks for watching the video. We're going outside real quick. Have a good one.